Hi and greetings to everyone. We are students from the Faculty of Civil Engineering, University Technology Mara UiTM Samarahan 2. Today we will be presenting our laboratory report for the course ECS268 Structural and Material Laboratory. The title of our experiment is Reactions, Internal Forces and Deflection of Statically Determinate Trusses.
But before we start, let me introduce our team. My name is Sofia Umang and this is my team members, Shen Benedict.
This experiment is a part of Level 1 laboratory activity, which means the problem and methods are guided, but the analysis and interpretation are left to the students. The purpose of this structured approach is to introduce us to independent learning and critical thinking in preparation for more open-ended tasks in the future. In this session, we were exposed to the proper use of apparatus and experimental procedures to analyze a statically determinate portal frame. The experiment helped us to better understand how external loads affect internal forces and displacement within a structural system. The main objective of the experiment is to determine the reaction forces, displacement, and internal shear force and bending moment in a portal frame subjected to external loading. At the end of this laboratory session, we are expected to be able to identify and correctly use the tools and apparatus for a plane frame experiment. Collaborate effectively in a group setting to carry out the assigned task and collect accurate data, analyze the result, and produce a comprehensive technical report.
Next, for the theoretical background, a portal frame is composed of members in the single plane. Loading is applied to the members, resulting in internal shear and moment as well as axial force in the members. A portal frame can be considered as statically determinate when the degree of indeterminacy is equal to 0 and the reactions at the support can be determined using equation of static only. Problem statement. The students are required to determine reaction, displacement, and internal shear and bending moment in a portal frame. The apparatus of this experiment is support frame, portal frame, dial gauge, vernier caliper, ruler, and one set of loads. Before we start our experiment, we need to measure the width of the member. Then, measure the thickness of the member. Next, place a load hanger at the location where the load is to be applied. Zero the dial gauge reading. Then place a load on the load hanger. Our first load is 10 Newton. Record the dial gauge reading. This represents the horizontal displacement at the roller support. Increase the load on the load hanger and record the dial gauge reading. Repeat step 5 for another 4 load increment. This is the table of the result data from the experiment, where the width of the member that we measured earlier is equal to 5 mm, and then the thickness of the member is equal to 5 mm. Then second moment of area, which can be calculated by width times thickness power of 3 over 12, that is equal to 260.42 millimeter. And then for the dial gauge reading, where one division is equal to 0.01 millimeter, and the table shows the data. To find the theoretical displacement value, it can be calculated by vertical deflection equal to applied load times length of the beam, power of 3 over 48 times Young modulus of the material times second moment of the area. Here, the length of the beam is equal to 300 mm and the Young modulus of the material is 70,000 Newton per millimeter square, and second moment of area equal to 260.42 millimeter power by 4. Then we just fill in the formula with the applied load. Start with 10 Newton, then 20 Newton, continue by 30 Newton, 14 Newton, 15 Newton, and 60 Newton. And for the graph, it can be interpreted from that data table just now, which is you can see that the displacement increased proportionally with the applied load because due to consistent linear elastic behavior. There is a slight deviation between experimental and theoretical values due to potential errors such as misalignment of the frame, friction in the dial gauge, and human reading error. And for the last part, which is references, we are using Structural Engineering Basics book by Johan D. 2025. Then we use Fundamentals of Structural Engineering, a problem-based approach by Mustafi T. 2024. And the last one is Truss and Frames, Recent Advance and New Perspective by Cantley A. 2020.